Hello everyone. Welcome to the breakathon organized by Scaleway tonight. I'm Romaric, CEO of Qovery, and I want to share with you some feedback using NATS at Qovery in production. So first of all, I just want to introduce myself. I used to be a developer and a DevOps in the past. I'm still very passionate about what I'm doing, but now I'm operating as a CEO, so I'm not supposed to develop and do technical stuff, but I like to present some of them. And yeah, I've been doing technical stuff for more than 10 years. And now what we try to do as a Qovery founder is helping any developers to deploy their application in the cloud in a very seamless way. So just to keep introducing Qovery, what we do basically is to help those developers to deploy their application because it's not their job to do that. It's the job of the DevOps. So the only things that they need to do is to get connected through Qovery to select the repository that they want to deploy with the different dependency that they need, like the database, the storage, the domain. And at the end, they can deploy their application on the cloud provider of their choice. So GitHub, AWS, Scaleway, DigitalOcean, all of them. It's possible with Qovery. And to do that, that's something that is quite important, is that we have to manage this infrastructure across the globe. Today, we have more than like 1,500 developers using the platform from more than 89 countries. And to do that, we had at some point to transmit the information, the data between the different parts of our infrastructure, and we had to use a broker. And this is where comes in NATS. So that's quite important. So if you don't know and you're not aware of NATS, that's why I'm presenting today the solution, because I know that's something, it's an incubated CNCF project for a long time. So it's something that it was developed for many years, but is not really known. But if you want to compare the solution NATS to RabbitMQ and a former Kafka solution, it's quite similar in some way. Meaning that you can connect, it's a broker that you can connect to your application to exchange different data. And the way that they are doing it is quite interesting, especially in the cloud native industry. And this is where really NATS shine. And I'm going to show you how. So first of all, you will see that NATS is very easy to install, very easy to implement on your side. So you have two ways to run it right away when you started, when you get into that documentation. So you have the most, we'll say, production way, like using Kubernetes, and you have the Docker way. And in just what you can see is just in one line of command, you can install and use a NATS. If you're familiar with still, I'm going to compare a lot with RabbitMQ and Kafka because I know that people are used to work with those solutions. If you compare to RabbitMQ and Kafka, you can see that it's quite easy to do. The NATS is also a messaging, cloud native messaging solution written in Go, very lightweight in terms of memory and CPU consumption. That's very important. You have like tons of, so all the most popular programming language are supported officially by the maintainers of NATS, but you also have some contribution from outside that are available. Here, I'm just going to show you the code that you, in just a few lines, like 20 lines of code in a synchronous way, in 19 lines of code in a asynchronous way, you can get access to the features of NATS. So starting to send message and then receive message. That's very, very easy to do. And to get into the way that we're using it at Qovery, what you have to imagine is that we, as I show you on the other slide, is that we are managing infrastructure across the globe. So how does it work? We have this part which is the control plane in charge of sending, managing, different access to the platform, managing the deployment of applications. So just receiving information through the different VCS provider, GitHub, GitLab, Bitbucket, and sending this information in instruction to what we call the engine. The engine is an open source module that we have made that is available on GitHub and is in charge of deploying the applications. And to get connected from those engines to the control plane, we're using NATS. Why? Because NATS is very cloud native aware of working. We expose our NATS in a very secure way, so it's managing TLS, all those things, and is exposed on internet. And our engines are connected to this to our control plane through NATS directly by initiating a TLS connection with our broker and get access and subscribe to all different messages. So this is how it works. Maybe just to get back a few seconds on the other slide, because I think it's important to compare to what you will get with, for instance, RabbitMQ, is that these dynamic subscriptions to any topic, any information that are going through this broker system is a bit more painful. Same for Kafka. You have, most of the time, you have to change some stuff manually. You have to put them into the configuration, reload the service, and let the service working. It's not always the case, but in some cases, it's what you have to do. This is where NATS really shines, because everything was made to subscribe very dynamically on any topic and then start to get access to those messages. So one thing, and that's maybe the continuity of what I just mentioned, is that we have this problem, which is to make the things very secure at Qovery. We decided to really isolate, but in a virtual way and also in a physical way, the traffic that are coming from our different customers. One thing that is important is the engine is, each customer has their own engine. We deploy this part on their cloud account, and this part must able to get access only to his traffic, and that's very, very important thing. And that's where NATS really shine as well, because you have this possibility to create a dynamic message routing. You can also use dynamic ACL to just isolate the traffic that are going through a specific topic, and the engine that are deployed and connect to this topic are only able to connect to this topic. So what you see here is, for instance, you have the possibility to broadcast on a key. So you have to provide, so each topic is a key that you provide, like engine, the customer ID, then the engine ID. And what you can do, for instance, is to say, okay, I'm going to send a message to all the different subscribers that are starting with engine and the customer ID, for instance, cust1. Then all the engines that are connected to this topic will receive the message. And this is the way you start to partition the different customers, how we partitionate the different customers, and the way that you can take advantage of NATS as well. So something that is very classic, I would say. You get this kind of feature on other broker system, but the way that is remade is quite easy to use. Something also that is quite interesting for us is when we start to run a customer, it will always start by running just a couple of messages. So you can have dozens of messages per second that are sent through NATS. So it means that it's okay, the traffic is not so high. But when you start to get more and more traffic, you have your consumer is getting lower, is consuming. So the consumer, which is the engine, is consuming in a lower speed than the producer itself is producing messages, and you have to bufferize those data. And what NATS provide built-in is a queue group system. So you can put a queue group. So it's a name. So you give the name dynamically. You can create a queue group to any subject, any topic, and then start to bufferize the different messages. So once a consumer is available to process and take the message and process it, then it can pick from this from this queue group. That's quite important. The advantage of using a queue group, as you also know, is that if you fail in any way on the consumer side and you need to just pick the message later on, then you can. That's a good way to prevent any failure and any lost messages. But everything of that is I would say the theoretical thing. It's but in practice you have some downside that you have to consider with NATS. One of them is that it's based on event loop system. So what does that mean? It means that if you have like a slow consumers that are starting to process the data, you have a system of acknowledgement. So you can if a producer sends a message, then it can request for an acknowledgement or not. If it's a request for an acknowledgement, then it will wait for the answer of the consumer. If the consumer doesn't respond to this acknowledgement right away, then you start to block the system. And that's the way NATS working. So if you are really intensively, I would say, NATS, you're better to use in a very asynchronous way, then you will get the maximum throughput on the system. That's very important. Otherwise, you will face to a slow consumer and low performance. There's one thing that I mentioned is that you have NATS is kind of the best combination that you can get from RabbitMQ and Kafka, but it's not as it's not exactly like that, because in fact, if you look at the different solutions that you have on the NATS, you have NATS that is a much more messaging broker system, and you have a Stan, which is the version, the Kafka version of their system, and you have to choose at some point how you want to use the system. If you are not aware of RabbitMQ and Kafka, so RabbitMQ is much more a broker system where you send a message and then you forget about this message, but you expect from the consumer to get the message. So that's quite important. You have the persistence part. And on Kafka, it's based on persistence. It means that it's very good for a high throughput. If you start to send tons of messages, then Kafka scale very well and start to write off the disk to just flush the data that he has in memory and start and be able to process it later. And what you get with NATS is exactly what you get with RabbitMQ, but with Stan, it's exactly what you get with Kafka. But the problem is that Stan is not as mature as Kafka. And today, I would say that there is not enough maturity to get into production with that. We're waiting for as a Qovery. We know that the NATS team is really active to work on this aspect, but we are still waiting a bit to use it as we would like in production. So that's something that you have to consider as well. The queue group, it's something that is quite painful on our side. There is no fair load balance. What does that mean? It means that if you are starting to use a queue group, then sometimes you will have like the same consumer that is taking twice a message. Okay, you have 3 consumers for the same queue group, and you will see that the same consumer is taking back to back the message that is coming through. And that's a bit painful, because when you have a system like us on Qovery, we have like a long task execution. What does that mean? It means that sometimes when we pick a task from the queue group that we are using through the engines, we have to wait for like 10 minutes to end the task, and that's quite painful, because when we can process only one by one those tasks, and getting into the random things of that, it's pain, because sometimes we have other workers that are just waiting for a new task, and they can't process the task because they were not assigned to them. So yeah, you have to be aware of that. If you're using NATS for high throughput, very short time of execution, then I think it's not going to be a big problem. But in our case, it is. So we are we report the problem to the core team, waiting for an answer. Maybe we'll find another way just to manage these kinds of things. Yeah, that's something. So no letterbox, if you know about like a common common messaging system like RabbitMQ, you expect from sometimes you have what is a letterbox? Is you have a consumer that is trying to pick a task and trying to execute it to do something with that, but a failure occurred, and what happens is that it's not acknowledged, but it's reported as probably there's something wrong. So what does the broker system is it takes the task and put it into a letterbox, and you don't have this with a NATS, which is quite painful, and especially in the case where you lose the connection. So when you lose the connection and one message was assigned to your consumer, if you in the meantime you lose the connection, then you lose all the messages. It's not something that you expect from a really resilient broker system. I think it's a design choice because at some point you have to make a compromise. But if you face this case, you have to be sure that your producer is aware that the tasks were not processed, then he can send back the answer. That's something that you have to just keep in mind when you're doing your design. Yeah, so to conclude, I really love, so for being in the industry for years, managing like RabbitMQ things, Kafka things as well, systems, I think, and that's why we made this choice of using NATS. It's a good compromise between like the resilience, between the availability, between the ease of use, between two different personas, which are the ops and the developer as well. As a developer and ops, I know that using NATS was quite straightforward. Just in a few minutes, like 5 minutes in your code, any kinds of code, we're using it with Kotlin, with Rust, with Go, with those three languages, and it works very, very fine. Even in Rust, that is quite, I would say, young. It works perfectly. It's very easy to use the library, the way that they were designed. The system is pretty good. Even on the upside, that's something that it's quite painful when you're using like RabbitMQ or Kafka. RabbitMQ is known to be not scalable at all. What does that mean? It means that when you start to have a cluster of RabbitMQ instances, it's a mess to just manage all of them. And Kafka, it's quite similar because you have to consider to add additional services. It's a scalable system, but it's also a high cost of maintenance at the end. And what's good with NATS is that they think about, okay, how can we package the things, how we can take advantage of the past, of the design decision that were made into other products to just make sure that it's not as painful as it was in the past. And that's exactly what you get with NATS. And that's very brilliant, in my opinion. You can install in just a few commands on Kubernetes, and it worked just fine. So very good. So thank you. That's it for that for NATS at Qovery. Thanks to the Scaleway team to invited me during the breakathon. It was just very, very good. And yeah, if you want to dig into Qovery, what we're doing, we are providing also a free tier for any developers that wants to host and deploy the application. Just jump into the product, use it. We have a Discord as well. And yeah, we are hiring as well. So thank you.